Hi guys, welcome to the lesson of ordinary differential equations. So the topic of our discussion is equations that are reducible to exact forms, and we discussed two cases. That is case number one, if dawa m over dawa y minus dawa n over dawa x divided by n is a function of x, then we simply find an integrating factor by integrating the function of x raising to the exponent. And then if we have dawa n over dawa x minus dawa m over dawa y divided by m, that is a function of y only, then we find the integrating factor by simply integrating the function raising to the exponential. Right now we will discuss case number three. When we don't actually get these both cases, then we have one more case. That is when we will get a function of xy, because if we have a function of this form, that is if m in our case is equals to y times f1 of xy, and then if n is equals to x times f2 of xy. This simply means that if we have a function m that is such that y multiplied by some function of xy, and n is a function such that x multiplied by a function of xy, then the integrating factor in this case will be simply equals to 1 over mx minus ny. But this cannot be always true. We may have some functions like this, but we don't get the integrating factor by using this formula, right? So we will check that in the later part, that how to evaluate that either we are getting a integrating factor or not by using this formula, right? So let's take an example. That is, the question is given y times xy plus 2x squared y squared dx plus x times xy minus x squared y squared dy is equals to 0. So we can see here that we have a function m that is multiplied by y here, this y, and we have n that is multiplied by x, and this here is f1 of xy, and this here is f2 of xy, right? And we can see that it's multiplied by x and this is multiplied by y. So we can use the trick here, and we can see that this equation is not exact. We can actually check by applying this partial m over partial y and partial n over partial x. So I'm writing it directly. In this case, these are not equal. You can check by yourself. So we'll find an integrating factor using this form. That is 1 over mx. So m in our case is y times x y plus 2x squared y squared, and n is equals to x times xy minus x squared y squared, right? So this is m and this is n. Now we can simply write like this: 1 over mx, which means that 1 over x y into xy plus 2x squared y squared minus ny, which means yx times xy minus x squared and y squared. Now we can simply simplify the denominator, so it will be x squared y squared plus 2x cubed y cube minus x squared y squared plus x cube y cube. So this will cancel out and we will only left with 1 over 3x cube and y cube. So that is actually the integrating factor for our case, and we will multiply this factor by the equation. So let's multiply the factor 1 over 3x cube y cube multiplied by y times x y plus 2x squared y squared dx plus 1 over 3x cube y cube times x, and then inside the bracket we have xy minus x squared y squared dy is equals to 0, right? Now we can check that this equation is the exact equation after multiplying with the integrating factor. So now we can simply, you can check whether now it's equal or not, and surely it will be equal because we multiplied by the integrating factor, and that will make these functions equal. So you can check by your own way. I will just solve this directly now by applying the technique of solving exact equations. So this is now exact equation. Then we can simply write in this way xy squared over 3x cube y cube plus 2x squared y cube divided by 3x cube y cube with this dx, and this will be integrated with respect to x, keeping y as constant. And then we have this one, that is x squared y over 3x cube y cube minus x cube y squared over 3x cube y cube, and this is dy is equals to 0, and we'll makes every function of x will be 0, right? Or function of xy. So wherever the x is involved, we will make it 0. Like here we can see that it's x squared and it's x cubed, so we will left with x in the denominator, so this will be 0 because we are making every function of x 0, and this will cancel out, therefore this will not be 0, right? So now we can simplify this one. So what we will get is 1 over 3 and times y, that will be treated as a constant here, and this is x squared, x over x cubed means x power -2 dx plus 2 over 3. This y will be cancel out, and we will left with 1 over x dx, and then here minus 1 over y dy. That is equals to 0, right? So we can integrate this function. This is x power -2 plus 1 over -2 plus 1 plus this is 2 over 3 times ln x minus this is ln y. Sorry, it's 1 over 3 here. So it's 1 over 3 times ln y is equals to c. And further simplification, we can get -1 over 3xy plus 2 over 3 ln x minus 1 over 3 ln y is equals to c. So this is the technique of solving these problems. Let's take one more example. Let's say we have xy sine xy plus cosine xy xy multiplied by y, and then we have dy plus xy sine xy minus cosine xy times x dy is equals to 0. And we have dx here, right? Now, first of all, we can see that we have a function y that is multiplied by f1 of x comma y, and we have a function of x that is multiplied by f2 of x comma y. Therefore, we can use the technique that is integrating factor is equals to 1 over mx minus ny. So let's do that. It's 1 over mx, that is xy times xy sine xy plus cosine xy, and then minus n times y means xy times xy sine xy minus cosine xy. So now we can simplify the denominator. So it will be x squared y squared sine x y plus xy cosine xy minus x squared y squared sine xy minus plus xy cosine xy. This will cancel out and we will left with 1 over xy cosine xy. So we can see that this is a integrating factor in our case, that is 2xy cosine xy. So this will be the integrating factor for our case. Now we can simply multiply the equation by this integrating factor. So what we will get is, let's see, this will be x y squared over 2xy cosine xy, and we have sine xy actually here, right? Then plus y times cosine xy is divided by 2xy cosine xy, and this is with dx plus we have x squared y over 2xy cosine xy, and we have sine xy in the numerator, then minus x cosine xy over 2xy cosine xy, and this is with dy, right, equals 0. So we can now integrate these functions simply by making y constant, because we know now this equation is exact, so y is constant and every function of x is 0, or function of xy, like that, wherever this x is involved, right? So here we'll get x and x will cancel out, so we will get 1 over 2 times y, that will be as a constant, and inside the bracket we have tangent xy dx plus, then here this will be cancel out, and cos xy cancel, 1 over 2 times 1 over x dx, and here this will be 0 because for functions of x here, and here x and x will cancel out, cosine xy will cancel out, and we will left with 1 over 2 times integral of 1 over y, that is equals to 0, right? So now we can integrate this function. So simply we have 1 over 2 times y into integral of tangent xy. So this will be ln sec x y, and then this will be over y, plus this will be 1 over 2 ln x, minus this is 1 over 2 ln y is equals to ln c. So this y will cancel out and we have 1 over 2 common, and then we can write ln sec xy minus ln y means this will be ln sec xy over y. And or we can do one more thing, or we can just leave it like that, and this will be ln c minus 1 over 2 ln x. So this is 1 over 2 times ln sec x y over y. So we can write it in this way, that is sorry, just let me write here. We can simplify it in a smart manner here. What I am going to do is I am going to write half ln x plus half ln c in place of this, or we can just simply take 1 upon 2 as common and we can shift to the right hand side, and it's a constant ln c, so it doesn't matter. So I can write it in this way: ln sec x y plus ln x minus ln y is equals to ln c1. Right, this 1 over 2 is common everywhere, so I shifted to the right hand side, multiplied by ln c and named it as ln c1. Right, so because it's a constant and it doesn't matter. Now we can simply write it as this is all ln everywhere, so we can write ln sec xy x times this one and divided by y is equals to ln c1, and we can shift this to the exponential power, that is e, to remove this ln. This ln will be cancelled out with e, so we're left with x secant xy is equals to y times c1. So that is the answer in this case, right? And that's the case number 3 that we discussed here. And in the next session, we will discuss case number 4 and then case number 5. And similarly, we will take some problems, probably 2 to 3 problems to have good understanding, and then you can solve questions. And if you are finding any difficulty, you can ask in the comment section, right? Thanks for the lesson, and that's all for the time being. Goodbye.